To explore linear algebra on the Pythagoras, click the application, then press Enter, Return, or click the check button. Then, counting left from the rightmost bead, select any bead, left-click, and press the right arrow key. This step generates x minus c, which will equal the gold beads against the right post. Next, to find m, the multiple of x minus c, from either group, count again. In this case, I will count again from the rightmost bead against the left post. 1, 2, 3. Click 3 and press again the right arrow key. Now, I have 3 gold beads at the bottom of the triangle here, which will equal m. 3 times x minus c equals 18. 3 times x minus c equals 18 y, which are the brown beads to the right and above the triangle, which has 3 gold beads at its bottom. There are 18 beads here. Next, I must generate C, and I can generate C from either group also. In this case, I will take 2 beads from the group against the right post, so I click and press the arrow key. And so I had 2. 3 times 2 gives me 6. So now I have my equation. 3x plus 6 equals 18. And I also have the solution to the equation, x, which will be whatever number of beads are left over here against the right post. So in this case, there are 4 beads against the right post. So that should be my solution, x. So, to solve for x in the equation 3x plus 6, I will first right-click the rightmost gold bead, so given the equation 3x plus 6 equals 18, with all the beads situated against the left post, I can now manipulate the triangle, the Pythagoras beads, to solve for x. First, by asking myself, m, 3 times what equals y, 18. And I decide that that is 6. So, starting at the rightmost bead, I count over 6. 1, 2, 3, 4, 5, 6. And when I click it, I get a beep. So I know that's correct. So I press or click the right arrow key. Then I ask myself, how do I get the 3 times x? So I look over here, since it's a positive 3, I look again to the beads against the left post, and I count 1, 2, 3. And the bead beeps, and I know that is the correct one. So I click and press the arrow key. Now I look at the B part of 3x plus 6 equals 18. And I ask myself, 6 divided by 3 equals what? So I know that it equals 2. And since it's positive, I take 2 beads, and I can see it clicked, it beeps, so I know it's correct one. And I click it, and I press the arrow key to displace it to the left. Now, if I look at the beads left against the right post, I see there are 4. So 4 should be my solution. To prove it, I will observe the algebraic solution to 3x plus 6 by pressing the down arrow. Took minus 6 from each side. 18 minus 6 gave me 12. Then I divided 3 both sides, and that gave me x equals 4, which are the number of beads now situated against the right post. Now, if I click the minus sign up here, it will transform my equation into its inverse. And so we see now we have the inverse. X divided by 3 minus 2 equals 4. Now the beads against the 4 are not the solution for x, but they are y. It is the inverse now, where x becomes y and y becomes x. And so if we look here, the 18 that was y now equals x. We can, on the Pythagoras, solve for x again by following the equation. The equation says that I have to add 2 to both sides. To my 4, I add 2. So I go over here, I click 1, 2 beads, and click the right arrow key, and add that 2 to my 4 to get 6. Now, it says that I have to multiply that 6 by 3. Multiplying by 3 also cancels this 3 and says my x equals 18. So here, I click 1, 2, 3, and with the right arrow key again, click it over, and it down will push out the quadrilateral of brown beads above the triangle that, of course, does equal 18. 3 times 6 equals 18.